All right, good folks. This is Tuesday, the 17th. Tuesday, the 17th, okay? We're going to do our warm-up first. Not working. There we go. We're going to do our warm-up first, okay? We're going to finish the notes from yesterday. Finish Unit 6 notes. Should take us that long. And then after which, I want you to watch the video and do the quiz review. We're doing equations and properties. Your homework for tonight, Tuesday problem. And I need you to study function, f of x. The notes say function notation. Please make sure you study all the notes on function notation. And that is make sure we cover everything. This was the property that we needed to look at. Justifying steps. We good with that one. Literal equations will be tomorrow. My function notation, I want us to do first. That one's easier. And that's this page right here. 24 function notation. All of this stuff. Okay? Substituting values in for x. And all of those things. Okay? Then knowing what f of x is. And this is the part that you'll be quizzed on. Being able to do this part. Okay? And then down here at the bottom. So please make sure that you read over these notes and that you know how to do this. Okay? Any questions? Let's take out our planner. Anybody still writing? Please raise your hand. I'll wait. Okay, let me pause it. All right, so your planner. Math 1. This is the 17th. Math 1. Now our homework problems, we already labeled. We have Math 1 homework help video. That seems to go okay yesterday. And then Math 1, we are studying. We need to make sure that we study function notation. Okay. Any questions? All right, please check off if you completed the homework, check it off. If you read over your notes on equations and properties, please check those things off also. I'm gonna pause for the calls, give you a chance to process. All right, let's look at our warm-up. Anybody still writing plan? Yes. All right, so let's look at. I can get it to you later. Let's just do it. All right, it says a line y equals mx plus b passes through this point right here, and it's parallel to this line right here. What is your b? So you have to figure out what your b is, and then you need to multiply this together, okay? I'm going to pause, give you a chance to answer those questions. All right, so this is what you should have. You see how we substitute the x and the y and m? Okay, remember parallel lines have the same slope. So if this slope is 3, then the slope of the other line is also 3. So you substitute the numbers into slope-intercept form and you get negative 22. Here you multiply, use the FOIL method, first, outer, inner, last. The 2 in the middle are going to be the ones, so this should be plus, sorry. Plus 5. So a lot of people got that one right too. Well, only 3 people got both of them right. Okay? All right, so we got to work on that. Questions, comments, or concerns? Yes, ma'am.
I'm confused because
Which one?
The
Second?
first one.
Yeah.
Because the equation says y equals 3x plus 6.
Yeah, that's just, it's parallel to that line. It's parallel to that line. So that means that the other equation has a slope of 3. So you're finding b of the other equation, not this equation, of the other line. One line is going this way, and the other line is going this way. This is the one you're trying to find. This one already has, is this one. You gotta find the b for the other line.
Okay.
Take out the notes from yesterday, please, because, all right, good folks. We already did the percentages for the different quartiles. Okay, so your lower quartile, spell it out, is which percentile? 25 percentile. Then we got the median. What's the median?
50%.
The 50th percentile. Okay. Your UQ, what does that stand for?
Upper quartile.
Your upper quartile. What percentile is that in?
75.
75%. So that number is in the 75th percentile. Okay. Questions, comments, or concerns? Okay. The distribution is the shape of a graph, okay, either on a line plot or a dot plot, but it is how numbers are distributed. It's the shape of a graph. The shape of a graph. All right, here we go. If you have a normal distribution, let's suppose that we have, it could be a histogram of some sort, and we could have grades. We're talking about the number of people here, number of students. Okay? And then down here could be the grades we have from, what's the 0 range? 0 to 50. And then from 50 to 60, that's the F. And then we got D, C, and then we got your A. Let me make it a little bit so I can go to 100. Okay. Yes, sir.
What is the less students? What was it?
Yes, number of students.
Okay.
Yeah, number of students, and then grades along the bottom, okay? In many classes, this goes true for a lot of different classes, you always gonna have some people that have F's. Always gonna have some people that have F's, okay? You might have a few more that have D's. Right? You're probably gonna have a lot of people that have C's, okay? That's average. There's a lot of people that make C. That's why they say that's average. C is average. Okay. You might have a bit more fall in this category too. A lot of people making C's. Now you might have a little less people in the B category. And then even less than that, you only have a couple people making A's, okay? Well, not always, but this is usually how it works. This is approximately normal. This is a normal distributed, where most of the numbers fall in the middle. So when you see a shape that looks like this, where the hump is in the middle, this is approximately normal or a normal distribution, okay? Where the hump is in the center, okay? Where most of the numbers are clustered in the center. This is a normal distribution. Most people are average, they're in the middle. Pause, people still writing. The skew to the right is when the cluster is on the left side. So weird, but that means everything is pushed from the right into the left. So this time, the numbers, instead of using, I'm gonna use a different kind of graph this time so you'll know that it's not just with these kind of graphs, bless you baby, it's with other graphs as well. So let's use a line plot, and we're gonna put all of our values are gonna be clustered to the left side, okay? This is a skew to the right, when the numbers are pushed from the right to the left. So the numbers are clustered on the left side. Okay, the numbers are clustered on the left side. So you can almost imagine what a skew to the left is. What do you think that's going to be?
Cluster to the right.
Very good, y'all. Pause, give you a chance to write this. All right, I've been waiting on him most of the time.
You just went ahead and do the other graph.
I know, I'm surprised. The numbers here, I'm gonna use dot plots on this one. Just so you can see, you know, that it's the shape of different graphs. It's not just, you know, and it tapers off. You know, sometimes you might have, you know, a little outlier here and there. But for the most part, this is pushed to the left and this is pushed to the right. The numbers are clustered on the right side. Right. A lot of times they say this, they use the words tapered off, okay? And sometimes they'll call this part, the little skinny part, they'll say it's a tail. So I'm gonna make sure I say that to you. And the sides are tapered off. Pause, give you a chance to write. She said what time is it? Start on the back. All right. These are your centers, okay? Okay, these are the centers of a distribution, all right? You have mean. What's mean?
The
Nope, never mind.
The average of the numbers.
Oh, wow.
And we're going to talk about why they call them the centers here in a minute, but let's see if you remember the definition. The average of the numbers. Okay? What's the median?
the middle, like the middle.
The middle number. And what's the mode?
It's like the
highest.
The highest repeated
no,
number.
it's the most.
Okay, the number that appears the most. The number that appears the most. Those two things. pause. Some people are still writing, so I'm gonna pause. All right, good folks. Now, the centers part. With any distribution, you have to figure out what's the best way to represent that distribution. That's why we call all of these the center. Average, when you're in, let's do example right here. The best representation of grades is going to be average. Why would you think the best representation would not be median? Why is median not a good way? So if I took your grades, and I would call out, let's put an example of your grades up here. Let's say you got a 0, 0, 0, 0. Okay, let me make this fake. A 10, 15, 50, a 60, a 75, 100, and another 100, okay? All right, let's make this a 90. Okay, so now, why would I rather average the scores up than to just pick the number that's in the middle? I would move this down though.
Is that represented?
Would it be fair in every situation that if I took and put your numbers in order from least to greatest and I picked the number that's in the middle for that to be your score?
No,
Would you like that?
No.
Would any of you raise your hand if you like that? Okay, good. Because that's a poor representation of your grade. Okay? What about if I took and made it the number that appears the most, the mode? If I said, okay, your grade is going to be the mode, what would your grade be?
0.
Is that fair?
No.
No. Okay? So the best representation for grades is going to be the average for this situation. Not for all, but for this one it would be. Any questions about that? Okay. So now, let's do another one. Let's suppose, I'm just doing these different examples. Let's suppose that we did movie ratings like we did on yesterday, okay? So let's suppose that we're rating that movie again, Medea Goes to Jail. And we had some people that chose 1 as rating. We had a few people that chose 2 as a rating, a person that chose 3, a lot of people that chose 4, and maybe 1 person that chose 5, okay? So, what is the fairest rating to give this movie? Yes.
The mode.
The mode. The mode would be the best because it's the one that appears the most. In this particular situation, it's fair to give it a rating of a 4 because most people chose a 4. Any questions about that? Okay. Anybody lost? All right, let's do this one. In this scenario, let's suppose that we're writing a newsletter to parents or something. And in there, we're talking about average amount that people make, okay? All right, let's suppose that we have somebody that makes 1 million a year or something. And then we have somebody that makes 50K, 30K, okay, maybe 20K. And then we have maybe 2 people that make 20K a year, okay, or something like that. All right, so now look, what's the fairest here? What's gonna happen if we average all the numbers together? What's that gonna be? Don't tell me like
Very high.
it's gonna be very high. What's making it very high?
1 million.
The million. You see that? The million's gonna make the average. So we can't send a newsletter home saying, oh, most people make 80 or 100K because of that million, because that's not true. Most people don't make that. Okay, do you see that?
Right.
So finding the average in this situation is not going to be the best thing. All right. What about mode?
That's
So
gonna
most
be low,
people
though.
make 20,000. Do most people make the 20? No, because you got a meal here, you got 50 here, you got 30 here. You see that? The lowest end makes, but you can't. It's not fair to say that most of these people make 20,000. So the fairest thing to do is to find the middle number. Any questions about that? So that's why we call it centers, because for different particular situations, the mean, median, and mode is gonna best represent the data. It's not always the average. Some people think it's the fairest thing is the average all the numbers together. It's not. Some people think that lining the numbers up and finding the middle number is the best representation. It's not. And some people think that the mode is always the best representation, and it's not. It depends on the situation. Questions, comments, or concerns? Okay. All right, let's do this. Spreads. Okay, let's do the different spreads. And of course, when you think of a spread, it's how wide the numbers are. All these numbers are going to describe the length part of a distribution. Okay, so let's look at this. We got our range. What's the definition of range?
It's like from like one end to like another.
The range, that's a different definition, and you're right. Range can be called the Y values, but in statistics, how do I find the range of numbers? What does that actually mean?
The distance between the minimum and the maximum.
Very good. The distance between the minimum number, the smallest number in the list, and the largest number in the list. Does that make sense? Questions? Okay. So your range, and I'm going to use that word because I like it. The distance between the smallest and the largest number in the list. So that means you subtract the two to find the range. And we know the distance cannot be a negative number. So it's the largest minus the smallest. What about the IQR? Interquartile range. That's what that represents. What's your interquartile range?
The range of each quartile.
It's the distance from quartile to quartile. It's the distance from the lowest quartile to the upper quartile.
Oh.
So you subtract the quartiles from each other. Upper quartile minus lower quartile. All right, standard deviation is the average of how far the numbers or each number in the list is away from the average of the numbers. That's weird saying that, so I'm gonna slow it down a little bit. The standard deviation is the average of how far each number in the list is away from the mean. And I'll give you an example. I'll give you a short example here in a minute. Example. We're going to do this kind of by hand. You can do this on the calculator, but we're going to do it by hand first to find the standard deviation. All right, so here we go. All right, with standard deviation, first thing that you're going to do, let's do grades again, okay? Or let's do each person's grade. So let's suppose that Sue, let's do math grades. Let's suppose that Sue made a 50 in class. And Joanna did good. She made a 65. And then Mary Ann made a 70. And Lula Mae made a 40. And Billy Bob made a 80. and Bubble Yum made a 95, and Lulu made a 98. Okay? Let's add one more person. Johnny made a 42. Poor Johnny. Y'all got it? Okay, so now, bless his heart, Johnny is not doing it. All right, so now we gotta find the average of these numbers. So how do we find the average?
You add all them all up and then divide by how many numbers.
All right, so let's do this. All right, so let's add all these together. So we got 50 plus 65 plus 70 plus 40 plus 80 plus 95 plus 98. That's right, I pushed 95 twice, sorry y'all. And then plus the 42, right? How many people is that?
At least 2.
8 people. All right, so that gives us a total of 540. So how do we find the average
And
or
then
the
you
mean?
divide that by 8.
Let's divide that by 8, and this is gonna be the mean, okay? So let's divide it by, I should have did this out to the side, sorry, because I mean this space right in here. So this over here, 540 divided by 8. So what's 540 divided by 8?
67.5.
So that's the class average here. This is your mean, which is 67.5. This is my mean. You see that? So now we are going to figure out how far are each of these numbers away from the mean. Okay, so that's what we're going to do. So to figure out how far they are away from mean, we're going to just keep subtracting, right? So let's subtract. We got 67.5 minus the 50. And what does that give us?
17.
So this is 17.5. Then let's do 65. 65 minus 67.5. And what does that give us? 2.5, right?
It's negative 2.5.
Negative 2.5. Let's do 67.5 minus the 70. What does that give us?
No, what is that?
Wait, you
Oh,
switched
and
it.
I switched it back around, didn't I? Hold on.
That would be regular 265.
This is just regular 2.5. All right, so then we got 67.5 minus what? Oh, we didn't do 70? I thought we did 70.
65 is 2.5.
Yeah, well, didn't we do 70 already or no?
No, we didn't get to that.
So let's do 70.
Wait.
We forgot to erase the negative.
Negative,
Yeah, the 2.5 should have been regular.
this is negative 2.5, and this should just be positive 2.5. Okay, so let's do next.
It's the other way around.
No, it's
Because don't you?
Because originally you did 67.5 minus 50.
Minus 50.
Then you switched it.
all right, hold on. Let's start over. 67.5 minus the 50. 17.5. 67.5
Minus 65.
minus 65, 2.5. Okay, yeah. We're on the right track.
And then that was
And then what's 67.5 minus? I'm trying. Over here. I'm praying in my head that at some point they will stop, so I don't have to be a bad person and put you out. Okay. All right. Minus 40, and what does that give you?
27.
27.5. Let's do this one. 67.5. What is it?
it would be 12.5.
12.5. What's 95? That would be what? Come on, y'all.
Wouldn't
67.
those be negative?
What would that be?
would be
22.5. And what about negative? What about 98?
Oh yeah, negative. Never mind.
Negative 27.
This one right here,
Yeah.
negative 27, what?
0.5.
And this should be negative 2.
Oh yeah.
All right, what should this one be?
negative 30.
30.5. And the last one should be
25.5.
25.
All right, so now let's add these together. Add all of these together and divide by how many in the list?
8.
8. I need you to add it for me so that, because I don't have, you got my count. All right, outlier. What do you think your outlier is? Does
It's
anybody
like,
know?
isn't it like something that like you see a list and then like there's something like there's a number in the list that like is very different from everything else.
Okay, so it could be a number that's extremely smaller than where all the other numbers are clustered, or extremely larger. And these are the steps to finding the outlier. These are your steps to finding out if it's a true outlier. We'll do an example. We just won't do an example today. I'll give you several examples. Please make sure that you paste this in your notebook, but also be prepared to take a picture of this and submit it on Friday.